Greetings, my wonderful students. Today, we'll be looking at the real number system. Now, what are real numbers? Real numbers can be defined as the union of both rational and irrational numbers. They can be both positive or negative and are denoted by the symbol R. Real numbers can also be defined as numbers that can be found on the number line. These are numbers that we normally use and apply in the real world. Yes, that is real world application. I want you to look at these types of numbers that are found in the real number system. Natural numbers, whole numbers, integers, rational numbers, and irrational numbers. And see if you can actually write the definitions of these numbers. You may pause the video and then you check or compare your definition. Now let's look at the terms that we have. Natural numbers, whole numbers, integers, irrational numbers, and rational numbers. So for number one, which one of those would you say fit the description of number one? This is the set of negative and positive whole numbers including 0. Integers, then you are absolutely correct. Number two, this is the set of counting numbers. If you said natural numbers, then you are correct. Number three, this set of numbers that cannot be written as a fraction, whose numerator and denominator are integers. But it cannot be written like that. If you said irrational numbers, then you are absolutely correct. Number four, this is a set of natural numbers including 0. If you said whole numbers, then you're correct. This is a set of numbers that can be written as a fraction or decimal. That is, the numerator and denominator are integers. Well, if you said rational numbers, then bravo to you. So, did you get all right? I believe that. Congrats. From the set of numbers below, write all the numbers that belong to the different set of real numbers. Let's start with natural numbers. So now that you're finished, let's compare. Natural numbers. Which one of these numbers are natural numbers? Well, natural numbers are also known as counting numbers. So we'll start not from 0, but from 1. So that we 1, let's put 1, 5, that's correct. The square root of 9 is actually 3, so that should be involved. We have 5 already and 9, so this is correct. If you have these, it doesn't have to be in order, but typically put in order. So we put 1, square root of 9, 5, and 9. If you have square root of 9 after, that's fine. Alright, this is just indicating that square root of 9 is the same as 3. Whole numbers are natural numbers in addition to 0. What about integers? Integers are all whole numbers, including negative whole numbers as well. So we'll include all these numbers and select those that are negative but without fractional parts. And so we select negative 57, negative 1, and whole numbers from 0 onwards. Okay, what about rational numbers? Rational numbers are any number that can be written as a ratio. In fact, we see rational, we can see the word ratio in it. So in other words, in the numerator of the ratio, we have an integer, and in the denominator, we'll also have an integer. So rational numbers are basically numbers that can be written as a fraction, common fraction, an integer in the numerator and denominator. And so, selecting from the list, we'll have these numbers. Do you disagree with these? If we look at this, negative 57 can be written as a fraction, negative 57 over 1, where both negative 57 and 1 are integers. Negative 2 and 3 over 4, can that be written as a common fraction with an integer in the numerator and denominator? Sure. If we look at negative 2 and 3 over 4, we can convert it to improper fraction. 4 2's, 8 plus 3 is 11, so that's negative 11 divided by 4. In the numerator, we have an integer, And in the denominator, we also have an integer. Remember, integers are negative and positive whole numbers. Negative a half, we can write it as negative 1 over 2. And so we can clearly see we have an integer in the numerator and an integer in the denominator. Negative 1, 0, 1/3. 1 in the numerator is an integer, and 3 in the denominator, that's an integer. And we have 1 as well, that's clearly an integer. So it's a rational number, because 1 can be written as 1 over 1. 3 and 3.7. Is 3.7 a rational number? Can it be written as a fraction? Sure, 3.7 can be written as 3 and 7 over 10. This 0.7, the 7 is in the 10th place, meaning 7/10. So we can convert this to 10 3s 30 plus 7 37 over 10. And so now it's an improper fraction. However, we have an integer in the numerator and in the denominator. And the same thing goes for this fraction, 8 and 2/3. We can convert it to an improper fraction with an integer in the numerator as well as the denominator. Now, what about 13.333 and so forth? Now, the reason why we have it like this is because 13.33 and we put this dash on above implies that the 3 is recurring, goes on forever. But 0.333 going on forever can be written as a fraction. In fact, 2/3 is actually equal to 0.333 and so forth. So we can actually write it like this, 0.33, and put the dash above. This implies the 3 is recurring. So this 13.333 onwards can be written as 13 and 2/3. And of course that can be converted to 41 over 3. Since 3 times 13 is 39 plus 241 over 3. So we have an integer in the numerator as well as the denominator. And square root of 9, that's actually 3, which of course can be written as an integer in the numerator and in the denominator. So we have 3 in the numerator and 1 in the denominator. These are integers, and so this is a rational number. Again, what are rational numbers? Numbers that can be written as common fractions with integers in the numerator and denominator. Irrational numbers now cannot be written as common fractions. Of course, you can have a fraction. For instance, you could have square root of 3 over 2, but this is not an integer in the numerator. We wouldn't regard this as a rational number, but instead an irrational number. In fact, let's look at the set of numbers from this list that are irrational numbers, and we have pi. Now, what is pi? Pi is really the circumference of a circle divided by its diameter, and we'll get approximately 3.142, and that number will actually go on indefinitely. So we will definitely not have recurring digits, but they will continue going onwards. Non-recurring digit, non-terminating, it will never end. And so we cannot write this number as a fraction. It's not possible for us to do that. What we can write is an estimate of pi, and 3.14 is really an estimate. Okay, so in fact, when writing this, perhaps the best thing to do is to write approximation symbol. So we're approximating the value of pi at 3.142 or 3.14, and sometimes we have it as 22 over 7, but even that is not the exact value for pi. It's a very close representation of pi. So pi is really an irrational number since it cannot be written as a fraction. It's a non-terminating, can be written as a non-terminating decimal, meaning that it will never end, and it's non-recurring as well. Now, the square root of 3 is also an irrational number. You will not get an exact decimal, or neither would you be able to convert it into a fraction with an integer in the numerator as well as the denominator. Hope that was helpful. Now, what relationship exists between the different set of numbers? Well, all natural numbers are whole numbers. All natural numbers are whole numbers. When we think about the set of natural numbers, we have counting numbers 1, 2, 3, 4, and so on. So those are natural numbers. Keep on adding 1 successively. All natural numbers and whole numbers are integers. Well, what are whole numbers? Whole numbers consist of all natural numbers in addition to 0. So 0, 1, 2, 3, and so on. These are all whole numbers. From 1, 2, 3 onwards, these are natural numbers, and we add 0 to it, we have the set of whole numbers. All natural numbers, whole numbers, and integers are rational numbers. So, all natural numbers and whole numbers and integers are rational numbers. This is telling us that if we should extend the whole numbers to include negative numbers or negative whole numbers, rather, then we will have what we call the set of integers. So negative whole numbers and positive whole numbers, including 0, are what referred to as integers. And all of these numbers are from the set of rational numbers. Because including integers, we have natural numbers, 1, 2, 3 onwards. We have whole numbers, 0, 1, 2, 3 onwards. And integers from negative infinity with all negative whole numbers, negative 3, negative 2, negative 1, and so forth. All right, next, a number that is either rational or irrational. A number is either rational or irrational. It cannot be both. So now a rational number will consist of not just integers, but also numbers that can be written as a fraction. So for instance, we can have, in the set of rational numbers, we could have negative 2/5. While this is not an integer, the fraction itself, because an integer must be a whole number, and this is not a whole number, this is a fraction, and it cannot be written as a whole number. But because it has an integer in the numerator and denominator, we treat it as a rational number. All these negative and positive whole numbers can be written as fractions. So for instance, if I take negative 2, I can write it as an integer over an integer by putting negative 2 over 1. So it's still negative 2, but we see that it's a rational number written as a ratio. A number divided by another number, but both numbers are integers. So these are rational numbers. So these are rational numbers. Next, a number is either rational or irrational, but cannot be both. That's right. So if we talk about irrational numbers, those are numbers that cannot be written as a fraction, a common fraction with an integer in numerator and denominator. So we could have the square root of 3 that cannot be written as a rational number, that is a fraction with an integer in numerator and denominator, but it can be considered to be an irrational number. All natural whole numbers, integers, rational and irrationals make up the system of real numbers. They are all real numbers. So what relation exists between the different set of numbers? Here we have the set of real numbers, the universal set. And it includes rational numbers and irrational numbers. Now, because a rational number cannot be an irrational number and an irrational number cannot be a rational number, they are disjoint sets. They share no common member. So, therefore, they are separated. So in terms of rational numbers, we have like 3 over 5, 1.375, 26, 21.6, 3.56, 56, 56, 56 going on forever. These numbers are all rational numbers because they can be written as a fraction with integers in numerator and denominator. But they are not integers. Now, integers are those set of numbers that are positive are negative whole numbers. So instead of integers, within this circle, this purple circle, we have integers. All these numbers within this circle are integers, including the whole numbers are integers. So these integers, we have negative numbers, negative whole numbers, and we also have positive whole numbers, including 0. So these are the set of integers. But you've noticed that integers is a subset of rational numbers. So that means all of these numbers within this red circle, they are all rational numbers, since they can be written as a fraction with an integer in the numerator and denominator. Now whole numbers have whole numbers, positive whole numbers, including 0. So they are counting numbers. So here I can probably include that we have the set of natural numbers. Natural numbers. Okay, so the set of natural numbers will be positive numbers, counting numbers like 1, 2, 3, and so forth. So these are just some of the numbers. Irrational numbers, on the other hand, we cannot write them as a fraction with integers in numerator and denominator, like the square root of 2, the square root of 3, pi, square root of 772, and so forth. Hopefully that was helpful. Now, further classification of numbers. We have even numbers, odd numbers, prime numbers, and composite numbers. We'll also look at multiples and factors, LCM, lowest common multiples, and highest common factor. We'll look at all of these in the next video. That is part 2 coming up next.